Alex here from the chemistry crew, and today it's chemistry.
Nice. Okay. It's on my nose.
Yeah.
Afternoon all, we're going to do back titration calculation today. I've got Emmett in the background and, as usual, my master camera girl, Ava Richards. So let's get stuck into this. Now this question, okay, has been put on the Google Classroom, and I'm going to talk you through it. But remember, the back titration, the overall kind of picture. Don't look at me so close. The overall picture is you have something at the start in excess. You add a solid. You know what you had at the start. When you add the solid, it takes up some of the acid, and then you titrate that end bit and work out what you had, and then minus it from the bit at the start. I hope it makes more sense. That didn't sound much like it made much sense to me.
No, it didn't.
I'll ask my kids too as we go along.
Can I just say something?
Go on, put them on, Aves. Put them on.
Please like and subscribe if you're brand new, because why not? It's free.
It's free.
It is.
Okay. Oh, I don't know.
What?
Don't worry. Right, so using the back titration method, this is a typical question. 0.8 grams of impure chalk. Oh, that pen's not very good. I'll try and find... We can't pause neither, can we?
Let's go.
Don't worry. 0.8 grams of impure chalk reacted with 100 centimeters cubed of 1 molar hydrochloric acid. The mixture was put in volumetric class made up to 250. Now, even though it was put up to 250, the number of moles here won't change because that's literally just adding water. But 25 centimeters cubed of it was taken out. Now that is a big thing to make note of because that is a tenth of it coming out. A 25 centimeter portion of the solution required 8.5 centimeters cubed of 1 mole decimeter cubed sodium hydroxide for neutralization. And the question is, what percentage of calcium carbonate that we chucked in there was in the impure chalk? So first of all then, I'm going to put in my two triangles. And this one we're going to need at the very end. Number of moles, mass, MR. And then my next triangle,
Sorry.
don't worry, concentration equals number of moles over volume. Remember, volume must be in decimeters
Square.
cubed. Okay. Right, so it's up to us which way you want to do. But I'm going to do, there's obviously two reactions going on here. Calcium carbonate plus HCl goes to calcium chloride plus CO2 plus H2O because it's a metal carbonate plus acid. As you can see, we've got two hydrogens there, two chlorines there, so we have two. So in other words, it's a 1 to 2 reaction. Then the second reaction is sodium hydroxide plus the acid. So sodium hydroxide plus HCl goes to Emmanuel. Sorry, babe.
It keeps like focusing in and then focusing out.
Oh, don't worry, it's okay.
Okay.
NaCl plus H2O. So basically, acid plus alkali goes to salt plus base. Goes to salt plus water. Now, I'm going to decide, I think what I'll do first of all is I will work out how much we had at the start in terms of the hydrochloric acid. Okay, so we've got 100 centimeters cubed, so what do we need? We need number of moles, so HCl at start, I'll call it at start. So number of moles equals concentration, which was 1 times brackets 100 divided by 1000, which equals, where's my calculator? Sorry.
100 divided by 1000?
Yeah.
In that one?
No, it's 10 in there. 1 times 100 divided by 1000 equals 0.1. 0.1 moles. Okay. And remember, that is what we start with. And then the next part is this, okay? We're going to work out how many moles of leftover HCl was titrated against the sodium hydroxide. So at the start, leftover, so we've got Number of moles again equals concentration, which was 1 times 8.5 divided by 1000, which equals 1 times brackets 8.5 divided by 1000, which equals 8.5 times 10 to the minus 3 moles. Okay, now we've got one last little confusing bit here. We've got that 0.1 moles, but remember, when we titred this, we took out a tenth of that. So in other words, we need to do 8.5 times 10 to the minus 3, 8.5 times 10 to the minus 3, times 10, because we took 25 centimeters cubed from our 250 centimeter cubed solution. So we took a tenth out. So in other words, we worked out we got this, but this is only a tenth of it. So we times by 10, which gives us 0.85 moles. So that's what we got left over. That's what we had at the start. So how much did we use? Well, let's how much CaCO3? It's 0.1 minus 0.085, which equals 0.1 minus 0.085, which equals 0.015 moles left over. Okay. However, there's the next confusing bit. Remember, the 1-to-1 reaction, but this was a 1-to-2 reaction. So we've just worked out, now let me think about this, okay? We've just worked out the number of moles of HCl. But as it's a 1-to-2, we've got half as many moles of calcium carbonate. So we divide that by 2, which equals 7.5 times 10 to the minus 3 moles. As you can see, as you can see, there's loads of chemistry in this, and this is probably worth about 7 or 8 marks. So it's worth knowing this properly. But this is the first time we've done it, so bear with me, okay? So it says, done that thing again. It says 7.5 times 10 to the minus 3 moles. Therefore, we have 7.5 times 10 to the minus 3 moles of CaCO3. It says what percentage of calcium carbonate is present in impure chalk. Now this is where we use our next triangle. So we know moles, we know MR, we don't know mass. So mass equals 7.5 times 10 to the minus 3 times the MR of calcium carbonate. I wrote it down somewhere earlier. Equals 100. 100 times 100, which gives me 0.75 grams. Okay. Keep it on this one, yeah. 0.75 grams. Now at the start, we had 0.8 grams of impure chalk. What percentage of calcium carbonate is in the impure chalk? So 0.75 divided by 0.8 times 100 equals 93.75%. Okay, 93.75%. 2 points to note. Number one, I think the hardest bit here was the 250 and then the 25. We took out a tenth. And number two, you had to know that you had to write out your stoichiometry and your balanced equation. Calcium carbonate plus HCl is a 1-to-2 reaction. Sodium hydroxide is 1-to-1, which is nice. So if it's a double titration, sorry, a back titration, which is 1-to-1, 1-to-1, is a lot easier. But this one, I just found. Now, as I've said, make sure you have a go at doing this one now. So go through this, and then have a go at doing it yourself. See if you understand the concept. Email me if you don't want to, and then say something funny for me, so we can finish it off.
Beats popping, yo!
Nice. Ava, do you want to be in it?
No thanks.
Okay, right then. See you all later. I'm going to give you some hard past paper questions on this as well.
Okay.
Goodbye!